Hi, all. Good morning, good evening, and good afternoon. Welcome to our next blog in the EKS Anywhere saga series. You know that this saga series has been up for a while, exhibiting various use cases and scenarios around EKS Anywhere. And this time, I'm joined by my colleagues, Alexander. Hi, Alexander.
Hello.
And Madhavi.
Hi.
And in this particular blog, we will be demonstrating EKS Anywhere integration with PowerFlex, Dell's PowerFlex portfolio. It's a massive and robust scale-out architecture for the most prominent storage out there. So without further ado, let me first introduce my colleagues here. Alexander, over to you.
So thanks, Ambar. My name is Alex Halpe. I'm a software engineering manager for CSM, Container Storage Modules. It's a solution that enables our customers to take full advantage of our storage portfolios and the features in their cloud-native environments. Kubernetes, OpenShift, and thanks to Ambar now as well, EKS Anywhere, AWS.
So with this, I would say that we have a full-fledged portfolio for every Kubernetes distribution out there, matching CSI drivers for every storage platform of ours, right?
Yes, we're getting very close, so happy about that.
Madhvi, a quick introduction from you would help.
Hi, everyone. My name is Madhvi. I'm part of C4 team in APJ. I'm the solutions architect. The reason that I got into PowerFlex is because of Amber. When we were doing the Apex block storage, we were installing the 3.6 cluster, and now we are on to 4.5. Very eager to get my hands dirty with it. Thanks.
And most of you would know me prominently through this blog or otherwise personally, but I'm a part of the APJ pre-sales team and a part of the cloud and containers team within Dell. Our effort has been again to advocate, how we can integrate Kubernetes with our different platforms within Dell, right? So as I said, the focus of this particular video would be to render EKS Anywhere CSI integration with PowerFlex. Here's what we're going to do in this particular video. We will be deploying an EKS Anywhere cluster live. We already have a PowerFlex cluster, which is the storage cluster inside of our lab. And we will be deploying the CSI drivers and render a workload on top of EKS Anywhere, prominently MySQL, which is a very common use case. And then we will be demonstrating certain aspects in terms of, the volume creation, snapshots, restorals. How do we make sure that, workloads are targeted using node selectors and things like that. So it's going to be something very interesting, hopefully, for all of you. Okay. Let's begin. I'll set the context for everybody here. Let me share my screen to begin. So let me share my screen. Now, we are on a terminal, which is my EKS Anywhere administrator machine. If you've been following the blogs here, you would realize that most of my clusters have been rendered through this EKS Anywhere admin machine. This is the powerhouse to create all the EKS Anywhere clusters. The EKS Anywhere cluster itself is going to be rendered like all the previous use cases in a virtualized environment, which is running on top of vSphere. This is the folder in which you would see the cluster machines come up, right? And what we also have on this particular web browser is a GUI login to my PowerFlex storage, which will serve as the persistence layer for the EKS Anywhere cluster. Okay, so from the previous blogs, I think it should be very familiar now. The way to create the EKS Anywhere cluster would be to source the script called as create EKS Anywhere cluster with add-ons, right? This is a scripted, routine. Basically mimics the entire sequence of creating the cluster through the official document of, AWS. So let's hit, the script execution. Let's name the workload cluster Let's say we will call it as MCX Demo 1. Let's say that. Okay. MCX stands for, between me and Madhi, we find this term called as multi-cloud experience. So yeah, multi-cloud experience Demo 1. The management cluster also will be, in this case, it's a standalone workload cluster. So the management cluster name is also MCX Demo 1. I'm going to give it a quick IP address for the API server. Let's give it 10.204.111.55. It's a static IP from my own IP range here within the lab. We will be creating, a node pool based cluster, which will have multiple worker nodes, namely labeled as MD0, MD1, and MD2. Again, the size and the configuration of these node pools vary depending upon the use case. We will be targeting the node pool MD0, which has 3 worker nodes in it, to host the MySQL persistent database actually. Okay, so let's take a template file from here. Let's say the node pools YAML, and let's select, I'm going to go for 1.25. Although 1.27 is up, we will go with 1.25. Doesn't make too much of a difference right now. Now, as of now, the cluster creation has started. You can see that with the previous examples, likewise, the validations would happen first. Once the validations happen, the cluster machines would come into play, and then finally the cluster would be rendered, right? So while this happens, that could take about 12 to 15 minutes. We will pause the recording, and then once we are done with the cluster creation, I will resume the recording accordingly. Okay, so allow me to pause the recording. Okay, so it's been almost 15 minutes, and let's see the status of our cluster creation. You can see that the final statement clearly says that the cluster has been created. The EKS Anywhere cluster has been created. If you've been following the blog, I think it's self-explanatory as to what has happened. But let me just crisply showcase where the virtual machines have been created for our EKS Anywhere cluster. You can see that a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 virtual machines have been created as a part of this cluster. This features 3 etcd nodes, which are outside the control plane. So they are dedicated etcd nodes. There are 2 control plane nodes which do not have any MD reference. So demo 1, this one, and this one, right? So 2 control plane nodes, 3 etcd nodes, and then there are 7 worker nodes. And like I said, we are working with the node pool concept. So we've divvied up this particular node pool into 3 nodes for MD0 node pool. And this is going to be the target worker node pool for our MySQL deployment and the CSI driver deployment actually. MD1, MD2, generally I keep it as a part of a cluster template to accommodate any auto-scaling workloads and things like that do not need persistence for whatever reason, right? So I generally keep them outside the scope of persistence layer actually. That means we will not be deploying any CSI drivers on these. So our target node pool for the CSI driver deployment is going to be MD0, right? And this is basically, what it is. The entire 7 worker nodes are there for us to deploy anything that we want. Let's now switch over to the terminal itself. Okay. We named our cluster as MCX Demo 1. In order to access that, again, we have to set our kubectl context. So a quick script would help there. MCX Demo 1, by virtue of previous blogs, what this will do is basically set the kubectl context, and then I should be able to access my cluster from here on, right? So you can see that These are the same nodes that you saw in the vSphere, the 2 control plane nodes, this one, and the 7 worker nodes, MD0, MD1, MD2 node pools. You can see that we are running 1.25 of EKS core distro. You can see it here. Again, no surprises there. This is based on a Ubuntu operating system for the individual nodes, right? Now, let's just quickly see kubectl get namespaces. So you can see that we are in a default system. There are no explicit namespaces that we have manually created. Now, what we are going to do on this particular system, let me highlight the fact that we do have a PowerFlex as the persistence provider for our MySQL workload. So I'm going to quickly log into the PowerFlex system, okay, and show a little bit of the GUI. Okay. Now, so this is a unified storage system. It has capabilities around block and file and whatnot. Madhvi, you want to share some of your views around PowerFlex as such before we hit the execution?
I think one thing that stands out in PowerFlex is the scale-out architecture, like you mentioned. It's probably easier for us to keep adding extra when needed, especially in the context of Apex block storage over there.
Yeah.
Yeah.
Completely agree. I think an important point is that, from Dell's perspective, PowerFlex is the substrate based on which, a lot of our new offerings will have a common storage layer, and the technology in use, whether it's Apex cloud platforms, which are on-premises cloud platforms for hybrid contexts, the underlying storage will also be based on the same technology of PowerFlex, or whether it be the Apex block over AWS. The underlying substrate for storage again is going to come from the PowerFlex, right? So likewise, so it's a very important platform in Dell's portfolio. Again, there are a lot of white papers and performance benchmarkings to see how this platform is really meant for those monstrous workloads. And again, it doesn't mean that it's not meant for smaller workloads, but really the beasts where you need that amount of performance at a price point which is very competitive. Anyway, so we have a block context here, and in that there are many different concepts around this platform. But one of the concepts is around the SDS layer, which is the software defined storage layer. You can see that I have employed 3 nodes in particular, 3 nodes which are going to serve and the overall storage capacity for this persistence layer, roughly about 800 gigs per node is what I've kind of accommodated. Again, this is a demo setup. It doesn't mean that this is the total capacity in its limitations. You can scale out as much as you want, right, to a really high limit. Anyway, so the point is that we are on the GUI of PowerFlex. Okay, we do have an EKS Anywhere cluster. Okay, so that's two components: the EKS Anywhere cluster and the PowerFlex platform. Now, what we need is the tie between the two, which is the CSI, right? And this is where the entire integration piece comes into play. If I was to glance through, Dell's CSI page, you could easily observe that. Let me just Google it up. Dell CSI PowerFlex. So you can see that there's a CSI driver for Dell PowerFlex. Again, it's an open source project, like Alexander mentioned. Correct, Alexander?
Correct.
And a lot of our customers have been using this CSI driver. The point is that there's an entire process or a procedure or a routine in terms of how to install, or if you want to kind of contribute to the project, so be it, right? There is an installation guide which will actually take you to the link of how do we install the entire driver, either using Helm or the Dell CSI operator, or you could do an offline installation as well, right? In this method, we are going to use the CSI driver installation using Helm. Okay. Again, if you want to go step by step, so you can see that there are subsections if you want to do this installation for which of our underlying platforms. Here we need to do it for PowerFlex. So I hop over to PowerFlex. So there's a number of things that you need to go step by step. What we've done is optimize the entire deployment and script it into a single script, right? And that's my passion of making sure that it's simple and straight. So all the steps that are here, right? Whatever that you see in this particular page is now created as a script, let's say that, right? And what we are going to do now is to execute that particular script. Okay. And let's get into this particular folder for my cluster, which was automatically created as a part of the EKS Anywhere cluster creation. Okay. Now I'm going to get the installation script from my GitHub repository that I maintain for EKS Anywhere. So you can see that this is the Cloud Garage / EKS Anywhere. I hope you're familiar with the GitHub repository. Everything that the blog has the corresponding code configurations, templates, everything bundled in this particular GitHub. Now, what we're going to do is go to the PowerFlex directory here, okay? And I'm going to grab this particular script from here, okay? It says install PowerFlex CSI drivers on notebooks, right? And I'm going to take this particular script. I'm going to download it here. Okay, let's make the script executable. Okay, so we do have the script here now. And I'm going to run this particular script. And let's see what all the scripts are. So there are certain inputs to that script that we can provide or we will need to provide, such that whatever steps that you saw on the CSI GitHub page, whatever automation is there is executed through the script by virtue of the inputs that we provide. The cluster name on which we intend to install this is MCX Demo 1. This will make sure that our volumes have the prefix of the cluster name when they are seen in the PowerFlex GUI. So MCX Demo 1, the release number that we are going to work with for the CSI is 2.6.0. There are more, this is so maybe, it'll be good, Alexander, for you to kind of, chime about how frequently do we release, what's our release process around the CSI and things like that. Any thoughts there?
Yeah, absolutely. So CSI driver for PowerFlex is part of the CSM container storage modules portfolio. So we have similar drivers that support other platforms as well, PowerStore, PowerScale, PowerMax, Unity. We are releasing on a quarterly basis. So every 3 months we have a new release. Usually what we're doing is we are implementing any feature requests that come in. Again, we're open source, so we are open to feature requests from the community, contributions there. We are making sure that we're qualifying with the latest cloud native environments for OpenShift and for Kubernetes and RKS and MKE as well, and now EKS Anywhere as well. Making sure that we are basically on top of the industry compliance for those platforms as well. So every 3 months, actually we have a release coming up this week. So the next version of the driver and of CSM will be out in the middle of this week.
Okay, so good to hear that we keep at pace with how Kubernetes evolves, and then we ensure that our CSI drivers are in line with those the Kubernetes release cycle as well, right?
Correct.
Okay, so we will insert 2.6.0 as the CSI release that we will work with. Now, this is an important thing. So the PowerFlex cluster, has an IP address that we saw in terms of the GUI. and the CSI driver or the software-defined client on our Kubernetes node will need to speak to that entity. So I have to provide for that particular IP address in that case. So it's for me, it's 10.204.111.91. Okay. In PowerFlex, there is a concept of metadata managers, which are called as MDMs. Since this is a cluster, the state of the cluster is defined and kind of maintained by the MDMs, which work in tandem to ensure that high availability and the distribution of the entire, the storage data is kept intact with regards to the state of the cluster. So MDM is an important concept in PowerFlex. If you read about the platform, you will have a affinity for those concepts and terms. For this particular exercise, I'm just going to limit it to inserting the MDM IP addresses, which are actually virtual machines as a part of my PowerFlex cluster here, right? So for me, the MDM IP addresses are 10.204.111.85.86 and 10.204.111.87. Now, what's going to happen is the CSI drivers, wherever they get installed on the MD0 nodes, there is a client like an iSCSI client would work with an iSCSI array. In this, there is a software-defined client that works with the PowerFlex. This client needs to know the endpoint and as well as the MDM IP addresses for it to kind of communicate and retrieve the data about the state of the cluster and the entities within and all. So this 3 IP addresses that I'm going to supply will help the Kubernetes node on which the CSI driver is installed communicate with the PowerFlex cluster and kind of do whatever is required there. Okay, now it also needs a specific system ID, which is actually a unique ID for the PowerFlex cluster. I have already retrieved it and kept it ready for our handy use. So I'm going to grab that particular system ID. Okay. Also, it would need a username and password in order to kind of authenticate and do various operations with regards to the CSI, right? So let me take this. Okay. Now the script also asks. Now this is not a part of the default routine steps that you see on the CSI page, but in this case, the script also asks us to provide for the node selector group name. What it will do is that as a part of the CSI drivers, and I'll show it to you, there are controller pods that get established and then node pods that get established, right? Where they will be deployed on which node pool is rendered through the node selector value in the YAML template for that CSI driver. So it's just that the script will ask for this input and it will do a search and replace in the YAML template, right? So let me provide MD0 as the node pool. You recall that we have 3 node pools there in the EKS Anywhere cluster, MD0, MD1, and MD2. So let MD0 be the node pool. You can see that the script has started executing. First, it is cloning the CSI PowerFlex GitHub. Okay. There's a lot of things that will do, but it's also needing support from external snapshotter, and that step just happened in the backend, which is used to create volume snapshots and things like that. Again, external snapshotter is an open source project that is used under the hood to create volume snapshots and restores and things like that, right? So now, as of now, you can see that the step has gone to a state where it's installing the driver. It's getting the SDC, the software-defined client config from the underlying MD0 nodes, and then it's asserting the MDM IP addresses and the configurations. You can see that there have been 2 statements here waiting for deployment. We expect OS controller pods to be ready, which is a success, so good, and the node pods, which is also a success, so which is also good. The script, you can see it literally took a minute, maybe, Madhvi, minute or minute, less than a minute. correct?
minute.
Okay.
Yeah.
So what has happened in the background, and I will tell you basically, external snapshot has been installed. The CSI drivers for PowerFlex have been installed. There is a storage class which has been created for PowerFlex, and there is a volume snapshot class also which has been created for PowerFlex, such that when we deploy our PVCs, the storage class that will be used is there rendered through this template. And when we create volume snapshots, this is the template that we'll use. Now I'll just showcase these things to you clearly. So let's just first see kubectl get ns. So you will see that there is a new namespace that has come up. This is called as VxFlex OS. Pardon the naming. VxFlex is the original name for our PowerFlex systems, and then it graduated with many different feature sets. But we kind of held the legacy of that term called as VxFlex OS. Regardless, let's get into this particular namespace and see kubectl get pods -n VxFlex OS. And you would be seeing that there are 2 controller pods. Again, you can increase the number of controller pods, but I've just kept them to 2, and 3 node pods. Now, this is a deployment, and this is a daemon set. Okay. By virtue of a daemon set, it ensures that since there are 3 MD0 nodes, there are 3 node pods that actually get created. Okay, 1 on each of the MD0 nodes. As far as the controller goes, it's floating between these 3 nodes. There are 5 containers basically, that are a part of the controller deployment, and there are 2 containers as a part of the node deployment. Again, from a controller perspective, you will have various containers as opposed to for attacher, provisioner, snapshotter, and likewise. There are about 5 of them actually, which do different functionalities within the deployment itself actually. And as far as the node, it's basically the driver is of essence, and there is one more. Now, we can see that the CSI drivers as such have been installed successfully. Okay. We can now get on to showcasing a workload on top of that. But before we do that, we can also get into the PowerFlex system here. Okay. And verify if these particular IP addresses are seen. So you can see that there are different end hosts which have registered with the PowerFlex system as the SDC client. We have to quickly, let's see if I can get kubectl get nodes. Okay, we can grab it from here. Let's say from the vSphere environment. Let's check the IP for MD0. So 184, 117, and 25. So 184, 117, and 25. If I look into the PowerFlex system, so 184 is there, 117 is there, and 25 is there. And you can see that the protocol type is SDC, means that these 3 machines basically are now registered as end clients or hosts, which can consume the storage platform of PowerFlex. Okay, Madhvi, does it make sense? Anything you want to add there?
No. Can you go to the terminal and show us the storage class that it got deployed?
Sure.
Yeah.
So good thought. So let's look at this. There is already a standard, and pardon me, I've not changed both our defaults, but we'll be explicit in mentioning the storage class. So you can see that there is a storage class that gets defined. It's called as PowerFlex SC. The provisioner for that, you can see, is CSI VxFlex OS delemc.com. We can keep it immediate, but we've kept it as wait for first consumer, so that when we create the pod, the PVCs will get rendered accordingly. Is it clear at this stage?
Yes.
Okay,
Thanks.
cool. So if this is clear, what we're going to do is deploy a sample workload. In order to we've kept one app ready. So what I'm going to do is I'm just going to clone my, so instead of cloning, I can also do, let's take this particular repository, EKS Anywhere, and I will go to MySQL standalone. And you can see that for the previous blogs, we have leveraged the same workload, for Unity NAS and PowerStore. Now we will go into PowerFlex. Now this is just, a sample app, nothing, major there. It's a MySQL deployment. And we will front end that particular MySQL with Adminer, which is a web-based UI to access MySQL and then, do various operations with MySQL from a GUI perspective, a web GUI, right? What I'm going to do is, for the simplicity of this demo, I've just, we will render this particular, URLs. We will fetch these URLs of the template files that we will use for the demo, mainly the Adminer deployment, the MySQL PVC deployment. Share here. The MySQL pod deployment. There's a dump.sql, which we will use to create the SQL entries in the MySQL database. And then there are two scripts that we have created to create a snapshot and then to restore the volume from the snapshot. And I'll explain it along the way as we go through, right? For now, what we will do is we will just get into this particular. So my variable is already exported, I think so, from a cluster name perspective. Let me see. Okay, yeah. So we are into a directory we've just created a directory called as PowerFlex inside of MCX demo 1, which is the clusters directory, home directory. And I'm going to just do a straight copy paste. And I know it's the most erroneous thing to do, a copy paste, but let's do that. So I'm going to take these URLs. Now, the point is, if you ask me where are these URLs stored, these are the same URLs which are here. All these assets are located in the context or under this particular. So I'm just going to, instead of cloning the entire GitHub repository, I'm just taking those specific files from here actually. If you have your own ways of deploying MySQL and things like that, so be it. Just make sure that the PVC has the storage class, which was the PowerFlex SC. Let me just grab these particular URLs here. Okay. Let me list them here. Okay, so I think all of them are here. I will change the permissions on the. Okay. So first things first, in order to deploy the Adminer, this EKS Anywhere, you know that from the previous blogs that we need a load balancer to expose our services. We could do it through Noteport, but we use MetalLB in order to facilitate a proper exposure of the services through a load balancer type. So what we are going to do is, before we start deploying anything, we will render, in this case, a MetalLB load balancer. How do we do that? I think the blog itself is there. I'm going to go and straight away, so that you can know that it works for real, I'm going to go to MetalLB load balancer services. This is the blog for the MetalLB. Let me copy paste MetalLB from here. Okay. So I'm going to deploy the help chart for MetalLB. And it will also create a namespace for the MetalLB pods. While this is happening, I will quickly copy the custom resource definitions for the IP address pool and the advertisement for MetalLB. We take this and tune it to my environment so that here itself. Okay, so the IPs that I'm going to give for my advertisement have to be from the range of my LAN. So let's give it 56. And let's give it just one IP. I need not more than one IP, so I'll keep it as 56 itself. Okay. So let's take this. Oh, copy paste. So now you can see that the metal LB has been deployed as such, okay, and it says that you can use to configure whatever, right? Now, let me see if the metal LB pods are running first before I start deploying the CRs. Okay, so we can see that there's tons of things that have been deployed, primarily metal LB controller and a daemon set for the speaker, which is across all the nodes actually, it doesn't matter, right? I'm going to deploy the custom resources, which are basically the address pool and the advertisement, so that metal LB can work with the services and then expose them based on what the requirements are actually, right? Okay, so you can see that the CR have been created. Now, when we deploy Adminer and expose it as the load balancer, we should be able to access it via the .56 IP. Okay, so let's do that. What we will do is we will first create adminer.yaml. This will also create a namespace called as demo, which does not exist as of now. So you can see that the namespace has been created, the service has been created, and a deployment has been created for Adminer. If we go and see the status of the pods in the demo namespace, so you can see Adminer is running. We will also get the service for, so you can see that Adminer, the type load balancer, has been exposed through this particular IP, which we configured it as a address pool in our metal LB load balancer. So if I hit this IP now, I should be able to access the Adminer GUI. So let's do that. Note that Adminer is a web-based GUI. As of now, it can't talk to anything. There's nothing that it can talk to. There's no MySQL deployed, or by the way, for people who haven't worked with Adminer, it can support different kind of backends from a GUI perspective. You can see the list here. Yeah, so it's a very handy tool that I use for MySQL, accessibility. Anyway, so we have deployed Adminer. Now, what we need is we need to define the MySQL PVC here. Okay, this is an important one, and if I do a cat on this MySQL PVC source.yaml, you can see that it's going to create an 8 gig volume, and it will utilize the PowerFlex SC storage class, which in turn uses this as the underlying driver to provision the volumes, right? Before moving ahead, I'll also kind of show that as of now, if I look into PowerFlex, there's just one volume, something that we would have created in the past, but other than this particular volume, there's nothing else, right? You don't see anything else. When we deploy our PVC and create the pod, you would see that there's a new volume that should come up, and that should validate the CSI deployment and the volume creation process through the CSI, right? Let's hop over to the terminal and let's create this particular PVC. Okay, so as of now, the PVC wouldn't be created because it's waiting for the first consumer. So if I look at the status of the PVC, you can see that the status is pending, but apparently the storage class is noted here. Now, what we will do is we will also look at the MySQL deployment. Okay, you can see that the MySQL deployment uses the same PVC, MySQL PV claim, which is what we saw up here actually, the PVC name. MySQL PV, PV claim, right? Okay, so we will deploy the MySQL workload. Okay, And you can see that the service and the deployment has been done. Now, if we look at the PVC, you can see that a new volume has been created. This is the volume ID or the volume name, MCX Demo 1. And this is what I said. Our CSI drivers have a way to prefix the volumes by virtue of, you can create different kind of prefixes. But this helps me identify, this volume belongs to which cluster and things like that, right? I can do a workload-based prefix. I can do a cluster. So it's up to me, right? So I generally keep a cluster-based prefix for me to identify the list of volumes in the GUI. If I look at the PowerFlex, you can see that this particular volume has been created. Again, it's a thin provision volume, size is 8, and one of the nodes in the 3 nodes within the MD0 would have basically picked up, the creation process depending upon, how the pod got deployed. So MySQL pod would have been deployed by virtue of node selector. Let me show you this also. If I look at the MySQL deployment, it says that it has to be deployed on a node selector with the group MD0. So obviously MySQL got deployed on one of the MD0 node pools. There is an underlying CSI driver on one of these 3 nodes, which would have picked up and then provisioned the volume. So, as of now, what we have validated is a quick understanding of how do we deploy a CSI driver, which is, a kind of, automated routine through a script between an EKS Anywhere cluster and a PowerFlex cluster, which is providing the persistence layer for, the MySQL workload. Any questions there or any thoughts, Madhvi, Alexander, anything from you to add?
Well, I certainly like the script that you had initially to deploy the cluster and have the input. So kind of a installation wizard type of deployment, which really helps, ease of deployment really for the drivers. So that's certainly something we're working on across all the platforms to have sort of a deployment that's the same across the board and that's really easy. Then ask for a few input params and covers a lot of the abstractions and the details that need to be configured in some of the cases.
Yeah, generally it happens so, right? When you're a storage administrator, you have a lot of things going on for you. You know the ins and outs of the storage platform. But as a Kubernetes user, right, or as a DevOps guy, I just need something automated, right? I need to provide a few inputs and, let the underlying routines take care of everything else, right? So yeah, we aim to help our customers through different levels of automation. Again, that in our Apex portfolio, we will be automating the entire thing through the Apex Navigator for Kubernetes, which is again an attempt to automate through a GUI-based process the deployment of the CSI drivers across our storage platforms, right?
Correct. Yeah. So deployment and management to that as well.
Yeah. Yeah. There are more things to a CSI driver as opposed to deployment only, which is upgrading the CSI driver or maintenance of the CSI driver and things like that. Yeah. So there is a lot of interesting work going on there from Alexander's team. Again, it's a community-driven project, so yeah, feel free to contribute accordingly. So for now, what we realize is that we do have a MySQL pod and an adminer pod. The MySQL pod is persisted, the data directory is persisted through the persistence layer via the CSI onto the PowerFlex system. Now what we will do is we will take the dump.sql. Okay, this is just a sample, database table that we will populate. Let me take this particular entry. Let's go to the adminer, the server. Since they are in the same cluster, we will use the MySQL name of the deployment. The username is root, whatever the password that we have set inside of the MySQL deployment. So So for now, this is as blank as it can be. We will create a database. Let's call it, so CSI test, let's say that. And we have a database that has been created. The database will persist over the volume that we have created. We will use the SQL command to populate the SQL table here. It's just a sample data set that describes some cars, let's say that, right? And let me execute this. Okay, we are done with this. So let me go back to the database here. So you can see that there is a new table that has been created under this particular database called a CSI test. If I get into the table, you can see that the data will have this kind of table, right? I mean, the ID of the car, the type, country, manufacturer, blah, blah, blah. So it's a sample data set. We will work with this data set to demonstrate certain things, right? Now that the data set is there, what can we think of doing, right? One is that we have established that the CSI integration is done, the volume has been created. One, we can edit the size of the, and we'll do it towards then the size editing actually. First, what we will do is, we've also demonstrated that the targeted node tool selectors are there for our CSI deployment, right? Which means the workloads can be very selectively targeted into a Kubernetes cluster, depending upon the affinity that you want to create with the underlying infrastructure. Okay. Second use case very prominently is the snapshots and the restoral of workloads through those snapshots. So in order to do that, what we will do is, if I now look at it, volume snapshots minus in demo. So as of now, there are no snapshots created, right? So here is a simple script basically that I've written to create a MySQL snapshot from the current data. So the database has been populated with a table called as cars, and there are some entries in it. So we are creating a point in time snapshot of that database with that table car. Okay. So namespace, am I saying restore? What happened? Yeah, okay, no, not restore. We have to create the snapshot. So create the snapshot. Okay. Whatever it happened in the backend, don't worry about it. You know how to create a volume snapshot, right? I mean, it's very simple in that sense, right? If you don't know, you can just cat this particular script and see what's happening. It's basically, there's a snapshot sample. It's copying it and just, rendering a snapshot.yaml. Snapshot.yaml would have basically a reference in terms of, creating a snapshot, from this particular persistent volume, which is the persistent volume that we have for our MySQL database. And there is a current state to this volume, which means that it is hosting that particular table inside of a CSI test database, right? For the MySQL deployment. So it's taking a snapshot, the source as this particular volume claim. It is using the snap class, which is the VxFlex snap class, to create a snapshot. And this is going to be the name of this particular snapshot. We've just kind of randomized the suffix to this particular snapshot name so that it reflects the date and time as we create snapshots and snapshots, to differentiate between different snapshots. And I mean, it's just a script, basis to kind of, just add in a reference or a suffix. You can see this here, right? SED, whatever date time, and $now. Okay, so we do have now a snapshot. Let me repeat the command to get the snapshot. Okay, now you can see that the snapshot has a name. It has an age, 96 seconds. It's ready to use. Yes, it's ready to use. The source PVC. Yes, the restore size, 8 gig. The snapshot class. And this is the snap content actually, with which it's supported actually. Now, apparently, if I go to the PowerFlex GUI, we now have a volume. Yeah, this was the volume. Plus, now this volume has a snapshot. So I should be able to see this particular snapshot inside of the PowerFlex also. So you can see that this is the snapshot that has been created, which just got created. Okay. And this is the name of that snapshot. If we were to correlate this, I think it should be able to correlate.
With the snapshot content, you could see that.
Yeah, snapshot. Yeah. Now, we are able to now demonstrate that not only we can create the volume, but we can actually snapshot it. By the way, it's using a tandem method with the external snapshotter to work alongside and create the snapshot on the PowerFlex system actually. Now that the snapshot has been created, what can we do? What can we do is we can now start creating chaos. Okay, so let's do one thing. Let's quickly drop this table. Okay, let's go to the database here. We will select our table and we will drop this table. It's the most dangerous thing to do in a production environment, but guess what? We've just dropped the table, knowing the fact that we have a snapshot which is already created, okay, from a previous run. Now what we will do, so as of now, just to kind of make sure that we are validating that the data has been lost completely, let's re-log in into MySQL, root, whatever is the password. You can see that the database is there, but no tables. So how do we recover it? Generally, the manual way would be that you recreate a PVC from the snapshot content or the snapshot, and then associate that particular PVC with the MySQL database, which means that as of now, if I get PVCs in the demo namespace, there is just one PVC, and this PVC has the table dropped now. But I do also have a snapshot I shared with you earlier. Oops, sorry. Okay. So now what we can do is manually either use this snapshot to create a second PVC, which means that you will have the restored data back into a PVC format or a persistent volume, and then drop this particular earlier PVC from the MySQL deployment and associate the new PVC with this. So what we are doing is, I've just kind of, for ease of our deployment, we've just kind of written a script here. It basically does the same thing. Okay, so you don't need to get into the script. Basically, it's doing the same thing. It's creating restore, whatever, and I'll show this to you. What is the content of this once I run the script. So let me run the restoral script here. Okay, so the namespace is demo. The script will basically scavenge and kind of find out what all snapshots are there in the Kubernetes environment in that particular namespace. Since we have taken only one snapshot, so it basically lists only that. I'm going to copy this particular. If I had multiple, it will give you a list of those snapshots. I will take this particular snapshot, put it as an input name as to this is the name of the snapshot from which the restoration has to happen. And we will just restore everything else actually. Okay. Now, hopefully, if the script has not been corrupted while I last deployed it. Okay. Let me just see. So you can see that there's a new template file that has been created here. It's called as MySQL restored PVC source cluster.yaml, whatever, right? And if I look at, there's a second PVC that has got created. Okay, the state is pending. Okay, and this is the new PVC from which we will recreate our MySQL database and validate the restoral process. Okay, let me just pause the recording for a while. Okay, so I think there was a slight glitch with the script that we have fixed. Nothing to be worried about. As you execute, and if you leverage this blog to execute, it should be automated. One of the template files, I did not retrieve it, and hence the error in terms of the file path. No worries. So now we do have basically, like I said, the PVCs. One is already the previous PVC, which now has the table dropped. And the second PVC, which was restored from a snapshot, but is still in the pending status because the earlier pod we have deleted. MySQL pod is not there now. Why it's not there? We have deleted. For it to be reassociated, we could manually edit the state of the pod and replace the PVC definition. It's as good as just deleting it. So I have basically a file that is the same file. It's called as MySQL restore source cluster. The only difference between the previous deployment and this deployment is the name of the PVC claim. Instead of this particular original name, this is the name that we have provided in the restore MySQL pod. Okay, we can quickly have a look at it. You can see that the claim name has been changed to the, so that we can now deploy the MySQL pod with the restored volume and see that our table exists in the new state actually. Okay, so let's deploy this MySQL restore source cluster. Okay. If I now look at the PVC status, you can see that the previous PVC exists, yes, and the new PVC also has been created. I mean, it's bound now. There should be a persistent volume that should have been created as a result of this particular PVC. It was in pending status. Now this has been created. Let's look at this particular volume inside of the PowerFlex system. Okay, so let's go to volumes. Okay, it should come up. Yeah. Now, let's also look at the status of the pods here. You can see that the MySQL pod is now up and running. Let's validate the persistence through the snapshotting procedure. So we will go back to our test database here. You can see that previously there were no tables. And after the restoral, let's do a relogin. MySQL root. So you can see that the database is there and the table also exists now. So this is a clear, validation of restoral of a persistent volume through the snapshotting process, wherein we could retrieve the drop table by recreating the volume. We can see the data should also exist. And that basically concludes the demo for this particular activity. There are a lot of other things that we can actually do and showcase, but primarily the goal of this particular blog was to showcase the CSI integration of EKS Anywhere with PowerFlex, and also highlight the volume snapshotting and restoral capabilities. I'm going to hand it over to Alex for some thoughts before we call it a day, in terms of what additional capabilities can be brought to bear here actually from a CSI perspective. Anyway, Alexander, over to you.
Thanks, Ambar. Yeah, great demo. And I want to thank you again for the contributions to the open source project on container storage modules. This is the kind of engagement we like to see, and to kind of showcase and broaden our support matrix there. So just this last example we did in terms of the snapshot we store on a local cluster, CSM has other modules and features enabled as well across the platforms. One is application mobility, which is sort of in the same arena. So that allows a Kubernetes admin to clone their stateful application workloads and data to other clusters, either on-prem or in the cloud, or replication. With replication, basically uses the native replication and disaster recovery features on the underlying array to copy either volume groups or snapshots over to other arrays that are on-prem.
Great. So I know that there's a lot going on, and before we conclude this particular part, in the near future, we are also putting in efforts to ensure that the demos around app mobility, replication, and specifically, interestingly, we plan to have a demo around how do we replicate between two systems of PowerFlex, wherein one end of it is hosted on an on-prem environment, the other PowerFlex system is hosted in AWS. You have a parity Kubernetes distribution with EKS Anywhere on premises and EKS in the cloud, which is the public service. And we demonstrate a replication of a stateful application, whether we call it from a cloud to ground or a ground to cloud perspective, right? So this is the strategy of Dell in terms of ground to cloud or cloud to ground. This is what we can establish a hybrid data plane and really make it a very practical demonstration of what it means to move data from one Kubernetes cluster to another when you have a very thoroughly foolproof way of establishing a storage fabric across a very potent system. So again, thanks Madhvi for your time, and Alexander. I hope the audience enjoyed the practicality of this blog with the demonstration in there. So thank you. Have a nice day or evening or night. Cheers.
Thank you, Ambar.